want to see the participants. Yeah. Okay. Well, I have to share screen.
No. Oh.
Okay, I think this would. Do people see this? Well, we'll see. Welcome, everyone. I think, I don't know how many people we have. Welcome to our panel here. I want to start off this panel by introducing the organizer of this panel, Linnea Selendi, who's done an incredible amount of work. She's the founder and chair of Horizon International, a group which seeks to find and advance solutions to the interrelated concerns of global health, the environment, and poverty. She gathered together 75 international experts to address these issues, which resulted in her conceiving and editing 2 books, which are widely used around the world. I know Linnea personally, so I also know that she's a wonderful human being. Here she has sent me her video of her introduction to this panel. And it should come up here.
And our changing climate. With a big smile, I'm sorry. The reality is just too overwhelmingly sad. The good thing is that because of COVID pandemic and the changing climate, humans all over the world have begun to realize the reality of the interconnected relationships that exist between humans and other forms of life. The realization that wherever we live and in whatever circumstances, we are interconnected, from the microorganisms in the soil to the fresh water we need to survive. How are our ecosystems doing? How is our ecosystem that is our planet? And how are our smaller ecosystems in which each of us live most of our lives? Our panelists will share their ideas, their wisdom, and ideas for action. As David Attenborough said, it's not too late to change.
Thank you all. So after Linnea recorded this, she asked me and sent me a copy. She asked me if I thought that such an emotional expression as she gave was appropriate for a meeting like this. And I said, well, it's certainly unusual. But then I thought about it a little bit, and I decided that it was very important. We're living through these horrible times and very likely to get worse. And emotion is very appropriate. Emotion motivates. And if we go through a whole meeting like this and no one changes, no one does anything, we wasted the meeting. So I told her that I thought this emotion thing was maybe the most important part of the whole meeting. I want to introduce you to my co-moderator. She is Professor Guigui Yao from Wuhan in China, and she has published on various aspects of environment and population and feminism and so forth, but I'll save time by not going into this. Our next speakers, we're rushing, are Doctors Jane Fisher and Tom Barker, whose picture you see, who are the lead academics at the Graduate School of the Environment at the Center for Alternative Technology in Wales. So we have people coming to us from that far away. Wales, part of Great Britain, as you know. And they're also at the Department of Geography and Planning at the University of Liverpool. Tom's expertise is in water science and environmental science. Jane's is in sustainability and adaptation. Now, Jane, are you going to present your thing, or am I going to present your video?
If you can run the video, that would be preferable. Say that again.
Say that again.
If you can run the video.
That's something weird.
Yeah. Here is your thing up, and I think it has sound. I should.
Click on that.
I can't hear you very well.
She said it would be preferable if you do it.
Yeah,
Okay,
just
yeah.
to do.
Okay, so I've got to. I have to do share screen again. Right? I have to click off share screen. I have to click on this one, share this one. Are you all seeing their presentation now? The PowerPoint of their presentation? What do you see? Yes, you're seeing. Okay, Jane, go ahead. Just tell me when to change the slide.
No, just click on that.
She has, it has sound on it, Bob.
Yeah, okay, so I should play it. Okay.
Make it smaller. Go to this one.
Slideshow. Here we go.
Hi, welcome to this talk on ecosystem health and how it's connected to human health. So this is going to be a quick and very brief look at how it is that biodiversity and connectants are connected to the health of humans, and it's by myself and
Mr. Whiteman.
Yeah. What's not?
For you all to hear, would that work?
Perfect.
Go
Okay,
ahead.
great. Okay, so it's just a quick presentation really to look at how ecosystems work or what we mean by ecosystem health. So there's lots of literature in the academic, in the science of ecosystem services, which really say that a healthy ecosystem is one which is productive. So it has biomass and it's growing. It can have a complex structure. And by that, we can include biodiversity as well as physical structure. And it's an ecosystem which is free from exotics and disease. And the general agreement is that if you have all of those things, that the ecosystem is what we term resilient. It's able to adapt to change and it's able to function. And we've put in here a brief summary of a functioning ecosystem, showing you how all the elements are interconnected. So this is a simple soil system here, showing you with energy, nutrients, and water resources coming in. And we're showing you how all the different organisms interact. So just briefly to explain why it is we need ecosystem diversity. And I've done these pictures here with these circles, and each circle represents a species. So the top line shows you a sequence of organisms, each one performing a different task. So it has a different niche within an ecosystem, trying to perform an ecosystem service. So this could, for example, be cleaning water through a wetland. So it could be that you have 4 species, each carrying out a function and thus cleaning water. But in this top picture, the the dotted arrows on the left, that's a simple ecosystem with relatively few species, and therefore the cleaning of water function isn't complete. The next arrow down shows you the same ecosystem now, but with more species, each able to form a slightly different step within the ecosystem. So each one now is able to fulfill a specific ecological task, which enables water to be cleaned. So it might be that one type of plant, for example, filters the water, then another range of plants uptake nitrogen and create denitrification, others hold on to phosphorus, then you have a range of microbes that might take out pollutants. And the bottom picture really is another fully functioning ecosystem, which is very diverse, but now we have many species which are overlapping. And this really brings us into the idea of, do we have this idea of functional redundancies? Are there so many species that we have many species performing the same task? And that last one is an example of an ecosystem, which is then very resilient. So if some species were to become extinct, we still have an ecosystem that is able to fulfill the processing. So really it's a schematic diagram really to show the importance of diversity. And again, on the right, we have an ecosystem, it's a pond, and it shows you how all these species are connected, feeding on each other from the primary producers at the bottom, up to the consumers, where it says water fleas, tadpole shrimps, up to the predators at the top. And you can see that the pike and the heron predators are actually feeding from many parts in the food chain. But commonly, we know that things like dragonflies, the orodonte can go extinct. They're very vulnerable to habitat changes. And if that happens, you can see now that the top predators become much more unsafe. They're more likely to become extinct because they have a fewer diversity to rely on. And I really wanted to show this picture really to remind everybody that much of the genetic diversity, much of the biodiversity we talk about is prokaryotic, so it's bacterial diversity. And this is an image taken from nature, and it's the sort of the best current understanding there is of the different genetic groupings that we have been identified. So you can see the top part of this sort of genome tree, as it were, are all bacteria. And you can contrast the diversity of these bacteria to the eukaryotes, the sort of higher cells, which are shown to the bottom right. And we are here. So humans are this tiny little offshoot down to the bottom right with all the animals, plants, algae and fungi. So really it's just a reminder that when we're talking about biodiversity and the role it plays in performing ecosystem services, much of that functioning is coming from bacteria, and much of the knowledge we have about what those bacteria are doing is frankly is non-existent. And much of that diversity as well is aquatic. And I've just put in a picture of one of my favorite aquatic microbes, which is a blue-green algae on the bottom. So we talked a bit about connection within an ecosystem, and this is a great example of connection between ecosystems. And again, just to show the complexity. So this isn't even considering microbials, this is moving up into the higher organisms. And this is a great study to show you how an internal terrestrial ecosystem, this is in, could be in Canada, it's the Northern Hemisphere, and how it connects to the nutrients and the energy coming in from the oceans. So what we see here is an ecosystem where the salmon, their seasonal migrations, after feeding out to sea, move up inland into the depths of these huge continents and bring with them all the nutrients and all the carbon from their feeding out to sea. And when they come up into the mid-continent of Canada, they're then predated upon by bears and other higher organisms, and therefore taking the nutrients onto the land. And you can see arrow B shows a salmon being eaten. And then those bears defecate, they leave bits of waste fish. So you've got arrows C's and D. And all those nutrients are then helping fertilize the forests and benefiting all those terrestrial ecosystem. And in turn, that forest is therefore dropping leaf litter, is dropping woody debris. So you look at arrows G and H, and that woody debris, that carbon, is in turn supporting the freshwater ecosystem and also trapping some of those salmon that have come up and thus keeping some of the nutrients higher up in the catchment. So we've got the aquatic environment bringing in nutrients from deep into sea, into the terrestrial continent, supporting the continental biodiversity and the continental biomass. And that in turn is supporting the freshwater, which then leads to next year's salmon spawning, going back out to sea, and so on. So it shows you the cycling really on a much greater scale. And just to remind us, that's just one example, but all ecosystems are connected, and we do have a tendency to conserve and manage ecosystems in a sort of little disparate groups rather than seeing them connected. And of course, there's human health implications for the loss of this diversity and connectivity. And there's a massive, you could have a huge list. So this is just a summary. So we know that the loss of global primary productivity, so in the oceans and on the land, tropical forests, is driving climate change. We know that the drainage of wetlands releases greenhouse gases, which in turn drives climate change. And we see the impact that has on human society. We see coastal examples, loss of mangroves, loss of vegetation high up in catchments, floodplains being disconnected from their rivers, simplified environments. And we know that that causes flooding in coastal and inland environments, which affects human health, our mental and physical health, our security. Food security is very reliant on soils. Soils are reliant on microbes, fungi, bacteria. They're related on climate. All of those are also linked together. So food security is obviously key to human health and well-being. There's papers showing sort of smaller scale examples, such as the loss of forests leading to rise of malaria. So simplified ecosystems where deforestation has led to an increase in malaria. And there's growing body of evidence showing that if we connect humans and we become more connected to nature, that benefits our well-being. But that's not to say there are not disservices. There are also papers out there which show you that sometimes a way to manage malaria, for example, has been to drain wetlands. And very recently with the COVID pandemic, we've seen zoonotic diseases spreading between various animal hosts into humans. And that's likely come about because we are going into these ecosystems. These ecosystems have evolved to connect to each other, and humans have become a new invader. So example from the World Health Organization, early evidence shows that the likelihood is that humans going into tropical forests, using those resources, has brought us into contact with animal hosts that we wouldn't normally come into contact with. And that has led and allowed a virus to jump from that animal host into humans. And COVID won't be the only disease that's obviously done that. There's still lots of uncertainty. And if we read the WHO reports, it does indicate that human societies are so complex, and obviously Chinese markets are bringing in food from all over the world. It's hard to pin down where the actual animals have come from. But no doubt it shows you that we are part of a connected ecosystem. And while that connectivity brings about essential life support systems, that connectivity also can lead rise to problems such as in the COVID pandemic. So of course, we all know, the possible solutions. How do you collapse that into a single slide? Restoration of ecosystem services means that we have to restore natural biomass, and that biomass needs to be diverse, it needs to be resilient through all those things we showed on the first slide in order to deliver those services. In some instances, restoring an ecosystem can be brought about by reintroducing a predator. Bringing about a top-down predator can help bring an ecosystem into balance, and there is various evidence that shows that that has been effective in reducing human disease. How do we go about that? At the root of it may be a lack of understanding and a lack of valuing of ecosystems, and particularly the functions of which they bring. A huge growing study into the economic valuation of ecosystems, such as through TEEB, which is the economics of ecosystems and biodiversity, and there's been a lot of academic work being done on that. Also, we've got to learn not to prevent people from using ecosystems. It's not, conservation shouldn't be a barrier. We've evolved to use ecosystems for food, for biodiversity, for fuel. So it's not the case that you need to keep people out. And that's been shown through marine protected areas where we've had conservation areas which have simply kept people out and has increased the use of zones further out and led to various conservation problems. It is likely that we do need greater understanding the links between ecosystem health and biodiversity for policymakers. But I have to say, I want to end on the fact that as scientists, we don't want to always be studying the minutiae, because we know the big picture and we know the problems. And I would push for more scientific voices around preserving ecosystems rather than for endlessly studying and trying to, well, measure how quickly the earth is burning, essentially. And that's brought us to the end. Sorry it was so swift, but hopefully I've given a quick overview there. I shall stop sharing. So I don't know if there's any time for any questions, or if anybody wants to put questions in the chat. We'll happily take those if there is time. It's talking. Did everybody hear that okay?
Yes, no problem. Heard it. Okay. Bit of distortion, but heard it. But I think Robert is on mute, so whether he's got questions, I don't know.
We're happy to take questions at the end if for time purposes you'd rather move on.
Now.
Okay, it's just trying to get it. There we go. Yeah, it's thanks for that. And that introduction is really very interesting, because you talked about ecosystems are disease-free, and in a way we are looking at here the question of man and water and disease, an ecosystem that perhaps has gone a little bit wrong. When we talk about NTDs, neglected tropical diseases, we think of parasites, we think of hygiene, we think of water sanitation. But when we talk about river blindness, it's really something that is related just to geography. If you are somewhere near an ideal fly breeding site where the vector is breeding, you're at risk. If you're living within a population who are infected and the vector is there, you're going to get the parasite. I got the parasite myself in the Central African Republic, just living in the area I'm living. This photo that you see here are 4 people looking at me just very close to where I was living. They're actually looking at me, but they're not seeing. I'm talking to them, asking them to look at me, but they're all blind. If you're in an area of river blindness, sometimes in some of these villages, up to 50% of adults can be blind. And this has obviously a major impact on the whole community. Now, why are these people blind? Well, they live near the River Wam, and you can see here these little rapids here, which are ideal breeding sites for the vector, the fly that transmits the disease. And here's some vegetation from a river. It's not the same river. I was trying to collect here from this river, and then a hippo popped his head up about 20 yards away, and I beat a hasty retreat. So this is someone else's photo. These are the vectors. These are the larvae of the vector stuck to vegetation. And this is where the flies are breeding in the water, and why the disease basically is called river blindness, because you have to live near a river. It doesn't have to be a big river. This is just a small tributary of the River Nile in South Sudan, in a place called Amadi. But you can see here, this lady's eye has gone opaque. It's cloudy there. And here you can see what actually, for an ophthalmologist, would say it's a cataract, but It's a secondary cataract. It's not operable because this patient sees absolutely nothing, although she has a cataract. So this is just the proximity that people have living close to the disease. Now, this is a little bit technical, but if you look here, you can see a pupil. That's the black bit, black circular bit. The iris is the brown bit, and this white bit is the cornea. But just look at all these different worms wiggling around in that space. I hope you can see them on your screens. These are the parasites that are in this patient's eyes. And it's hardly surprising that as a result, some of the patients end up having some problems. They actually have problems in all areas of their eye. All parts of their eye can have a problem. Perhaps one of the most dramatic ones is how this develops in the cornea, which is the clear part of the eye through which you normally see the iris and the pupil. And, you know, it develops here at the sort of 3 o'clock, 9 o'clock, and gradually fills in the bottom and gradually fills up until obviously this patient here can't see. So this is a progression over a few years, and it's related to being constantly reinfected with this same parasite. So this is why, obviously, it's called river blindness. Now, the effect of that is that some people just desert their village. Living close to the river is just impossible. They're all going blind. As I said, some villages, up to 50% of the adults will be blind. The young people want to leave. They can't see well enough to farm. So people are actually leaving fertile valleys, going to live on hills or in poor areas of poor earth and away from the river. And this obviously then creates poverty, and basically they get into a vicious cycle of poverty and disease. So this is the impact on communities, and this was very much the situation mostly in West Africa, just south of the Sahara, in the Sahel. This was the situation alongside a lot of rivers in these areas. But one of the things that we can now do is that we can actually kill those parasites with a drug called Ivermectin. Now, it says here MDA, that is mass drug administration, and CDTI, community directed, interesting, directed, not medically directed, community directed treatment with Ivermectin. And how does this happen? Well, this is some photos I took of a program in Burundi. Initially, there's a lot of sensitization of the population, because the population has to become involved in this process, because we need to distribute Ivermectin at least once a year, sometimes twice a year, for up to 20 years. So we don't kill the parasite straight off. Unfortunately, we can't kill the adult parasite. We can only kill the larva. So the population is sensitized, and then they're registered in a village register. And these boxes here are tablets that are actually donated free by Merck in the USA or MSD in the rest of the world. This is a donation given, and for river blindness, this amounts to somewhere around 200 million treatments a year and has been going on for years. It's also used for another disease called lymphatic filariasis. So the total is over 300 million people treated in many countries in the world. Once they've been registered, then we use a simple stick. You can see here measuring the height. That hand is on the yellow, which means he's got 3 tablets. If he was a bit higher, he'd have 4 tablets. So it's an easy program that you can organize with the community. And this empowers the community because they're able to carry out this treatment. Then tablets are counted out, 1, 2, 3, or 4. You don't treat children under 5. So it's a minimum of 1 tablet up to 4 tablets. Counted out, and it's actually a supervised dose to make sure that the patients really are taking this. And if the population, if 65% of the population take this tablet, the disease, the problems with river blindness, in the blindness, but it's also in the skin, and also creates epilepsy. So you've got various diseases that will reduce if you can get these tablets out. And if we want to eliminate the disease, which is now what we're talking about, we actually want to eliminate the transmission of this disease, get rid of the parasite completely, then if we can get coverage up to 80% of the total population, we have a chance of actually eliminating this disease. And this is now our new possibility, our new objective. This is a statue that I was given in Burkina Faso. You can see that even local artists, this is a theme of their sculptures. And you can see these sculptures anywhere. They have so much lived with blindness in parts of Burkina Faso, for example, but in other parts of West Africa as well. This has just got into their culture. But we hope that this is going to disappear as now blindness gradually disappears. So we can get rid of blindness. We can, if we can get enough of the population taking the tablets, we can achieve something. But when we're talking about the ecosystem, we still have those flies breeding in the river. We hope they're no longer infected flies, but they're still breeding in the river. Now that could be all right, but actually the flies, and I assure you, they are firstly painful bites and they're itching bites. There was a study done in the Congo where I worked, a place called Inga, where there's a big dam, and people there can get bitten up to 13,000 times every day, 13,000 times every day, just because of the mass of black flies. And although it's a tropical area, you see children going to school, wearing long sleeve shirts, gloves, hats, trying to protect themselves as much as possible from these flies. So a biting nuisance is really a problem that we have to look at. Now, having hopefully getting rid of the disease, what are we going to do for the ecosystem? Well, two things we can do. One is we can clear the vegetation that's in the river. And you can see here the villagers can get rid of some of this vegetation, but also you can create traps. The blue and the black attract the flies, and if there's a sticky surface, you can actually reduce, well, this is really used for diagnostic purposes, but we hope we might be able to develop these to reduce the number of flies. So it's not just getting rid of the disease, it's also having to live with these flies. So it's an ecosystem that is purely related on where you live and what's in the river. So these are some things you might want to discuss or talk about as we look into the ecosystem. But with that, a very quick, a very brief look at river blindness. Here's a beautiful river. This is in Kisangani in the DRC. And here you see traditional fishing going on at the Wagenya Falls. So thank you very much. And yeah, if there's any questions, that's fine.
Thank you. Thank you. I think we'll delay any questions till afterwards. We're running very, very late. So our next speaker is Linnea Selendi, who you can notice is quite young, and we wanted to include young pioneers in our group. She is surprisingly the granddaughter of Janine Selendi. She's 22 years old. She's binational. She grew up in Sweden, but attends Bates College and really goes back and forth. She's now an environmental major at Bates College in Maine, but she spent, I guess she'll tell you how she got into this problem. So, Linnea, you have to, Adrian, you stopped your screen share?
Yeah, I've stopped it.
Stopped it. Good. Linnea, start your screen share and the platform is yours. I see it. Yes.
Okay, there. Can you hear me? Okay, wonderful. Yes. Thank you so much for the introduction. I am going to be talking about mangroves, which, believe it or not, there are not a lot of mangroves in Sweden. So my passion for mangroves actually came about when I was abroad in Senegal for a semester during my junior year of college. So I'll be talking about that today. Oh, oops, there we go. Okay, so first off, what are mangroves? As you can see here, I took this photo up on the top right of your screen of mangroves that are in the water, and they are coastal saltwater trees that typically intertwine and form a sort of skeleton in the water. And there are lots of different types of mangroves. There are about 80 different species that are all around the world. Most of them are only found in tropical or subtropical regions, and the highest number of species are found in the South Pacific region. But the only mangroves I got to study and experience were the ones in Senegal. So here are some general reasons why we find mangroves important. I'm going to delve into these a little bit more later. First, they support fish habitats, especially during breeding season. They are extremely important for local fisheries and have a big cultural importance as well in Senegal. They also help with storm protection and erosion prevention, which I will delve into a little bit more later. Okay, so here I'm going to talk a little bit more about my experience in Toubacouta, Senegal, which is very close to the gold mine of mangroves in southern Senegal. Some of the first things, and you can see actually there I am on the boat. I don't know if you can see it, but one of the first things I noticed when we were going into the mangrove forest was that it's very secluded from the village, and that is for a reason. They want to protect the mangrove habitats away from people and keep them very secluded to prevent any disruption from human behavior. And one of the first things we got to do when we went into the forest was to just sit in silence and listen to the mangroves and its rich biodiversity and its ecosystem. And you could hear the clacking of the clans, and you could hear different creatures making their noises. And it was actually quite almost a spiritual experience, as we got to know later on. The mangroves have not only an economic and natural use for the villages, but also a spiritual one. We got to also see and learn that there's a cycle in the fish life that forms in the mangroves. The fish eggs are protected, and the baby fish are protected from predators in the mangroves because the predators can't get into the small creases in the mangrove trees. So that's the perfect breeding spot for fish. And that's why it's so important to keep the mangroves if you want a lot of fish for the villages and for the fishermen to get a lot of to catch a lot in the fishing season. They need to make sure that the mangroves are protected. And I'm going to delve into a little bit more of the cultural and economic importance of mangroves in southern Senegal. There are a lot of villages that are dependent on fishing and fisheries, so that to actually provide for families and also provide for the village, not only to feed the village, but also for commerce relations with other parts of Senegal. Let me see. So here's a little photo of me. This is me giving a presentation similar to this one, but a longer one and a more, I don't know, detailed one when I was in Senegal. But here are some key points that I wanted to bring up about the local and global importance of mangroves. Mangroves are extremely, extremely important for carbon storage. They can store 5 to 6 times more carbon than regular trees. So carbon sequestration is extremely, extremely valuable to have mangroves. And then also on another note, we got to learn about animism and how there is intrinsic value in mangroves. And I know that when we talk about ecosystems and values and biodiversity and all these kinds of things, I think that it's very easy to jump into numbers, and which are also very important. But it was also very interesting to learn about the cultural value of just experiencing life and how Senegalese locals thought of the mangrove as a sacred place that has intrinsic value not just because of how it affects fish production, but as a space that has intrinsic value.
Linnea, we should go on now. We should go on to Barry, to the next speaker.
Oh, I'm out of time.
Yes, way out.
Oh,
Yes.
okay. Okay. All right.
You know, I can see you can go. I mean, that's up to you. Your call, Bob. It's okay. My talk is going to be a little bit shorter, I think. So
Yeah,
up to you.
no, let's go on. Barry, so go ahead. Barry Levy is the past president of the American Public Health Association and also an adjunct professor of public health at Tufts School of Medicine. And he writes on various aspects of war and terrorism. So go ahead, Linnea, stop sharing your screen. And Barry's is up, good. Okay, Barry, go ahead.
Can you see my slide? Okay.
Yes.
Yeah. I apologize, Linnea. And
No.
can you see my next slide here? Okay. Okay, good. So I do want to talk about the impact of armed conflict and, in effect, war on ecosystems, and a few general points about war before going forward. One is that most wars are fought in low and middle income countries, in contrast to the war in Ukraine. In far-off places, Syria, Yemen, Sudan, in the last year or so, there have been almost 40 cases of armed conflict, 40 wars in the war. Some of them are small skirmishes. Some of them are major civil wars that have been going on for many years. Almost all of them are intra-state conflicts, in contrast to Russia's war in Ukraine. Civilians and civilian infrastructure are often targeted. So that means food supply systems, water supply systems. People have reduced access to water for lots of reasons because of war. Healthcare is often targeted. And wars cause widespread damage to the environment and ecosystems. And it's not only damage caused to the ecosystems by war, but also preparation for war, adverse effects on flora and fauna, damage to habitats, adverse effects on migration of animals and birds, including birds, chemical contamination of air, water, and soil, landmines and unexploded ordnance, as we're seeing now in Ukraine, and how that impacts the ecology, and diversion. Very importantly, and often not thought about, is the fact that war diverts human and financial resources so that there's less human financial resources available to protect and address issues in the environment and in ecology in general. I'm going to talk a little bit about mangroves as well, picking up from Linnea, and that is, here's a picture of physical damage to the environment, specifically to a mangrove forest during the Vietnam War. These are bomb craters from U.S. and Allied forces bombing Vietnam. And they created these craters in which mosquitoes and other disease-bearing vectors easily breed. And so there's not only immediate effects of the bombing, but long-term effects on ecology and human health. There's chemical contamination of air, water, and soil. I'm going to give some examples. Here, a picture of the oil well fires ignited by retreating Iraqi troops during the Gulf War in 1991 or so. You know, this is a very dramatic picture, but of much greater consequence, and something you don't see with dramatic pictures per se, is the extensive use of fossil fuels during war that in turn creates greenhouse gases and leads to climate change. It accounts for this is almost a million years shown in this graph, and the sudden uptick starting really in the first part of the last century of CO2 levels, continuing more recently, continuing unabated. The level of CO2 in the air is now 421 parts per million. Higher than it's been for since these levels have been measured. Impacts of climate change in ecosystems. I'm just going to touch on this briefly, but of course, increased temperature, changes in precipitation with more droughts and more floods in various places, but almost everywhere, more of the precipitation that falls in heavy downpours, as we saw in the Dallas-Fort Worth area just in the last few days, and in the Southwest. Extreme weather events like hurricanes and cyclones, sea level rise perhaps by a foot or more by the end of the century, acidification of the oceans, which has important impacts on ecology as well as human health. For example, to the extent that oceans are acidified, it leads to the saltwater incursion increasingly on groundwater systems, which in turn impacts human health and impacts the ecology as well, and then changes in the pathogens and vectors of disease as a result of climate change. Another way in which a war and the preparation for war affects the environment is radiological radiation contamination. We're concerned about that right now in the war in Ukraine. This is a picture in near Chelyabinsk, Russia, over the Teka River. The person holding the Geiger counter is reading the fact that on the Geiger counter, the radiation level is 280 times, almost 300 times above the acceptable normal level. And this is because nuclear weapons were made at the Chelyabinsk facility, just a few miles upstream from where this picture was taken, accounting for the massive radioactive contamination of the environment from nuclear weapons production. And we're not even talking about nuclear reactor meltdowns such as that in Chernobyl, which has had profound impacts on ecology and the environment in that area. This is spraying of Agent Orange, a very toxic pesticide by United States and Allied forces during the Vietnam War, again, having profound effects on the environment, including, once again, destruction of mangrove forests, as shown here, as a result of the toxic and carcinogenic components of Agent Orange. Preparation for war, as I just touched on briefly, also has major impacts on the environment and ecology in terms of air pollution, a contamination of soil and groundwater with organic solvents and other chemicals, as is occurring at many U.S. Military bases, destruction of habitats, and many wars are actually resource wars where people are trying to extract resources from the environment and causing vast damage to the environment and to ecology. We're also concerned about long-term effects, particularly from, or for example, from persistent bioaccumulative and toxic compounds, such as the so-called PFAS, perfluoroalkyl substances that are now getting more and more attention. In 2001 is one example of the long-term effects of war. In 2011, soil levels of lead and copper was still increased in some areas around Ypres in Belgium, which was a major World War I battlefield. So more than 100 years after the battle was fought, there's still evidence of heavy metal toxic contamination of the environment. And landmines as unexploded ordnance, as already shown. Here's a tripwire, a landmine. Here is a diagram of a person trying to remove a landmine. There are tens of thousands of landmines around the world that make farmland unusable, make it impossible not only for humans, but make it dangerous for animals, at least land-based animals, to cross those areas. And for example, in the current war in Ukraine, there's extensive mining by Russian troops that will make areas not only unusable by humans, but dangerous to animals for many years to come. So war and the preparation of war also divert large amounts of human financial resources that could otherwise be used to protect and preserve ecosystems. The United States military, as you may well know, spends $800 billion. That is our country, our government spends $800 billion on military expenditures, more than the next 11 countries combined. Those next 11 countries altogether still do not exceed the amount of money we spend on military expenses. Between 1950 and 2000, more than 90% of major wars occurred in countries that contained biodiversity hotspots, so that war has tremendous adverse effects on biodiversity, including accelerating the loss of species, degrading habitats and ecosystems, interrupting conservation programs, and impeding research. So there are fewer resources to prevent poaching. Soldiers use wildlife. The impacts on wildlife are profound. Soldiers often use wildlife for food and take and sell animal parts, and war forces local people to turn to poaching and bushmeat trade just in order to survive. There's now over 100 million people in the world displaced. We're talking about refugees and internally displaced persons, more than there's ever been before. And just from the Ukraine war alone, more than 12 12 million people displaced. This is causes, and through no fault of the refugees and internally displaced persons, but it causes damage to habitats, deforestation, as refugees and internally displaced people use forest, cutting down trees in order to have fuel to cook and to keep themselves warm, use of fresh water, contamination of water and soil, and again, adverse effects on wildlife. And here are some of the effects specifically on the war in Ukraine: air pollution from explosions and fires and their impact on ecology, water and soil contamination, vast deployment of landmines, and much unexploded ordnance, and the potential for radiation exposure, not only from the nuclear reactors, but also the threat of Russia's use of nuclear weapons. In my book, Hard to Hope, I talk in part about the impacts on war on the environment and ecology, but also I talk a lot about hope, and there is a lot of reason for hope. More and more people are engaged in addressing these issues. The International Committee on the Red Cross, and I'm citing some of their guidelines, and this in the next 3 slides, specifically from their book entitled Guidelines on the Protection of the Natural Environment from Armed Conflict from a couple of years ago. But they talk about specific protections for the environment under international humanitarian law, such as no widespread and banning widespread and severe damage to the environment, not using destruction of the environment as a weapon. Also, some general protections under international humanitarian law, as shown here, rules concerning banning or restriction of specific weapons that are likely to cause extensive damage to the environment and to ecology, and ensuring greater respect for international law that protects the natural environment. So in conclusion, some of the things that can be done include improving protection and preservation of ecosystems, not only during war, but before war, and also in the aftermath of war, increasing education of policymakers and the general public about these issues, and preventing war and promoting peace. And that can be done in 3 ways. I know this seems, unbelievably impossible and difficult, but every step in this direction is important to ultimately achieving a world without war, resolving disputes nonviolently, reducing the underlying causes of war, such as poor governance, militarism, ethnic rivalries and tensions and so forth, and then strengthening the infrastructure for peace. So thank you for this opportunity, and I'll be happy to try to answer any questions at the end.
Thank you very much, Barry. That's one heck of an important topic. And Francis wrote us a question. Thanks you for the presentation, and he can relate for that very much because of what's going on in my hometown in the eastern part of Nigeria. There's an ongoing armed conflict right there at this time. And the environment and the ecosystem have been greatly affected negatively because of this. Insecurity has also greatly increased, and women and children are the worst affected, as access to water and daily basic human needs are not available. I think you two will have a chance to answer this question and discuss more about it afterwards, but I think we have to charge right on. And our next talk is going to be fun, and it is information from Francis. And Barry, have you turned off your share screen? Yes, okay. So now I'm going to try to share this screen. Can people see Francis' picture here? Yes?
Yes.
Yes.
Okay, so because the internet is so bad, the connection to Nigeria is not very good from where Francis is. He's asked me to actually do the reading of his slides, but he's there and can answer questions and so forth. So this is Francis Umenu Odebute, and he's with the Nigerian Observer newspapers, is chairman of the WASH Media Journalist Network of the Edo State chapter. He's CEO of African Press Cartoons and president of, I love this name, Beautiful Feet International. What he does is makes cartoons of various sort that educates the local Nigerian people, especially the children, about their health concerns and what the related environment helps. And there's a set of comic books, wonderful comic books, put out by Wash 4, which is Water, Sanitation, and Health. And this set is about Nigeria. And he also has school meetings at schools, meetings even outdoors, and is a great educator and outreach person in Nigeria. He is in Benin City, not the country, Benin City in Nigeria. And so he's sent us some of his cartoons that will give you a flavor of how he presents this. And so here, rather than water scarcity in many parts of the world, Nigeria, being in the tropical rain belt, has too much water often, and flooding is the big issue there. And flood water, you can't drink it because it's mixed in with everything else. So this woman says, water, water everywhere, yet no water to drink. I think you'll recognize that quote from some other famous person. Here's another cartoon. Beware of flood and be safe. So the houses can get washed away, many of them made of mud, and you have to build barriers against the flood. Another cartoon, oops, what is this one? And of course, avoid building houses on the waterways. The water is going to flood, you know that, rather periodically. And if you build your house too close, boom, it's gone. And with the overpopulation, there's not much space for people, so everybody can go on to the river plain. This is very serious in Bangladesh. Here's a very important thing that the people themselves can do. Do not dump refuse anyhow, anywhere, because when a flood comes, you dump the garbage in some drainage ditch or something, then the flood comes and that garbage is in your house and where your children walk and so forth. And these drainage channels have to be cleared, clear drainage of refuse regularly. And farmers, he's telling farmers, their grain is, if it's on the ground, is going to get washed out or gotten wet and then rotten. So it's very important for the food supply. Farmers, use elevated storage for your farm products. Erect high nets around your fish ponds. Very crucial advice. There's some uplands there away from the river basin itself. Where possible, cultivate on uplands. And if you have to use lowlands, plant early before the floods come so that you may have your harvest before the floods are going to wash it away. Another thing, of course, is that electric poles get knocked down, transmission poles. And when the electricity dangles in the water conducts electricity, anybody steps in it, like this person, can get electrocuted, and people have died with that. That can be probably in Nigeria 220 volts. So very, very dangerous. His advice, when you notice flood, avoid contact with electric cables. Don't try to touch them yourself, and disconnect the power supply to your house, because your house current can also go into the water. Protect your health against flood. Flood water is contaminated. Don't drink it. Very sound advice, but people don't always understand that. They see water, I can drink it, because you can't see the bacteria, the viruses, the parasites in the water. And because people do need some water, if you must use flood water, boil or treat it first with chlorine or with water guard, which is another killer of the parasites. So, malaria, always sleep under insecticide-treated net. In flooded neighborhoods, of course, malaria mosquitoes breed in standing water, and after a flood, there's plenty of standing water. You get a burst of mosquitoes, you get malaria. So his advice is always sleep under insecticide-treated nets to prevent outbreak of malaria in flooded communities. And here's the thing that people, sometimes they don't have toilet facilities, they defecate outdoors. Francis says how bad that is. Avoid defecating into the water to prevent cholera outbreak. Open defecation endangers public health. Stop it. Not only your health, but it can spread. One person gets cholera, the whole village can get into trouble. And how you stop that is wash your hands with soap. Very key public health invention. And the last slide here is if you feel sick, avoid self-medication. Don't go to the local uneducated person, but go to the community health clinic. They will know what to do. These are all very, very critical advices. So I think, Francis, do you have any last word that you want to say from this?
Yes. What I want to say is that with the awareness we are creating in school, young people are being carried along, in the education and awareness about the importance of keeping yourself healthy. Nigeria is a most populated country, and so many people are still having poor sanitation and poor hygiene. But with this infographic method of educating the public and enlightening them, especially young people, we are getting progress, and a lot of persons are changing their behaviors as it concerns water and sanitation. And we are yet to do more. We want to take the campaign to more schools and more communities around the country. I don't know if you heard me. Did you hear me?
Yes. Okay. Thank you very much. Yes, we could hear all of that. We're going to rush on because we're very close to being out of time, and I'm last. So I am going to share my screen here, and I hope you can all see that one now, the big globe with drops of water on it. Can you see that? Yes. Okay, good.
Yeah.
So in this last session here, I want to blow up the scale of what we're talking about. And the scale I want to address is the total amount of water on Earth. And here's the Earth. You can see dry of water. You can see the ocean bottoms here. All of that water has been pulled together and collected in one bowl. This is the size of that bowl for the whole Earth's water. It fits into this little bowl. And this is all water. This is the ocean water. This is the liquid fresh water that you can see. It's water in the underground areas. It's all water on Earth, and it's this very small bowl. Of that small bowl of fresh water, of this big bowl, it's almost all salt water. This is the amount of fresh water. This is what humans could potentially use. You could drink it, you could use it for agriculture, possibly for some industry. This is all that we have to possibly use. And of that, 70% of the fresh water is used for agriculture. So when we talk about water scarcity, the issue is agriculture. And agriculture is needed because people have to eat. And we're not doing very well on that score. For instance, this is the largest reservoir in the United States. This is the Hoover Dam, and it's Lake Mead behind it. This is when, in 1983, not so long ago, when the Hoover Dam was full. And this is the level where the water should be. This is what it's designed for. But now, look at the water level. 3/4 of this is gone. And this is the rest is a disaster. The Hoover Dam feeds not only the agriculture in California and Arizona, but Los Angeles, San Diego, Las Vegas. This is a major disaster, which is just about to happen. And this is just right at the dam. All the water flows down. The water that's left flows down to this place upstream, and around at the edges of what you see, it's this. This is Lake Mead, the biggest reservoir in America, and most of it is just plain caked mud. And you see even the fish that were there have died. That's the biggest reservoir in America, but that's not alone. Here's the second biggest reservoir in America. This is Lake Powell on the Colorado River. Same story. The water used to be up even to here, Now there's nothing there. It's going down tremendously. And this reservoir used to be 30 million cubic meters of water. Gone. Global warming is some of the problem here, but it's not the main problem. The main loss of the water is through irrigation. It's our need for food. The humans have to eat. And as the river comes from the melting snow in the mountains, as it flows down into the valleys, the farms along the way pump out the water, pump out the water, pump out the water, and use it for irrigation. The rivers no longer fill the reservoirs that I've shown you, and most of them do not get to the sea in growing season. So what I've showed you is just the loss of surface water, but that's the smallest part of the problem. Most of the water that we use for agriculture is underground. We call it groundwater, even though it's really underground water. And to give you a sense of the scale of that, this is all the water on Earth. This is the oceans. Can't use that. Here is the fresh water. This tiny bit is fresh water. That blown up, most of this fresh water is glaciers in Antarctica, in Greenland, and that's not usable by humans either. There's no people living in Antarctica that can grow food there. So what we're left with is lakes and river storage, which I've shown you is going. That's 0.3%. That's tiny. Most of the available liquid water is in groundwater. 100 times as much is below the soil, which you cannot see, as is above the soil that you can't see. So this is what we worry about. It's 99% of, more than 99% of the water that's possibly usable by humans. The Green Revolution, which saved humankind from massive starvation in the 60s and until now, depended on huge amounts of extra fresh water. Already before the Green Revolution, the rivers were basically used up for irrigation, as I've mentioned to you already. So was not extra river water to use or lake water. So where did the extra water come from? It was pumped up from underground. That the pumping in the world exploded. There's now nearly half of all the agriculture on Earth is irrigated, and is irrigated from groundwater, not from river water. It's a primary source of water for over 1 billion people. Just to look at 3 of the locations that are in water scarcity: the Indo-Gangetic Plain, which is India, Pakistan, to some degree Bangladesh, and time is going up here too. That feeds 800 million people. The North China Plain, 420 million people. California, which I've shown you the pictures of, peanuts, only 40 million people. This is where the real issues are, where massive starvation can occur. If water disappears here, we're in real trouble. What farmers then do is try to dig deeper and deeper. But the aquifer underneath that carries was only so deep, and eventually they reach the bottom, and then there was no more water for that farm, and the farm disappears. Western United States, this is happening all over. Here's an example, and not from the worst part of, and not from the driest part. This is up in Oregon, which is generally considered a wet place. And here's a well in a farm, and in 1965, actually, the water was about 160 feet down. You had to drill it. In the next 50 years, it dropped by 100 feet. That's the water level. And the farmer keeps have to drill more, drill more, drill more. And how much more you can drill, I don't know. But in the regions where groundwater is not drilled up and not sprayed upon, it's desert. There's nothing there. This is what's happening out west and in all different parts of the world. You may realize that the land level is that there's water underneath, and that holds up the land. The land floats somewhat on the water. If you draw out the water, the land collapses. Land collapses. This slide shows you in California that in 1925, the land was up here. The water was sucked out, the water table fell, the land collapsed into it. 30 years later, the water table, the land level was here. 1977, 22 years later, the land level is down here. Now, that's when the really massive irrigation starts, much more. And we've had several decades more pumping out of water, but we don't have a picture like this. There's other ways of looking at it, but it's a disaster. And I saw this week that the Rhine River in Germany, that supports half of Europe's population and runs between Germany and France, that's risks running dry. So we're really in deep, deep trouble. And I want to give you a sense of the scale of this, because I told you the surface water is tiny. So in South Asia, the capacity of the 203 largest reservoirs and the largest lake in India's breadbasket in the North India is about 40 billion metric tons, this much. That's collected over decades, centuries. In that same grain belt, the loss of groundwater, we can tell from satellites how much groundwater is getting gone, is equal to this, 40 billion metric tons. That means that every year from the underground aquifer, it's the same amount of water that's lost as all the lakes and rivers and all the water that you can see. This is a really major, major thing. And here is a satellite viewed from a satellite. This is the water loss in this South India, Pakistan, Afghanistan, Tibet, up here. And this is where the grain belt is in Pakistan and India, and this is where the water is disappearing. To give you an idea of the quantitative comparison here, this is California. California peaked in about 2005, not that long ago. Since then, the water level down, 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 down until here. And we think, I've shown you the pictures, we think that's bad. But look at the North China Plain, the breadbasket of the Yellow River in China. That peaked a little bit before, about 2003. That peaked, but then since then down, 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 down. And now the North China Plain is this low. And the worst case is where I've shown you in India, that India starts the highest. There was a very productive area, Punjab in India, Punjab in Pakistan, very, very productive area, but pumping gets very strong, very high, down, 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 down. And now India is in this desperate, desperate situation. So to conclude, humans are squeezing every last drop of water out of the earth. And why? Obviously, it's needed to feed the 8 billion people on Earth. And it's getting worse. Here is the population of the Earth, the whole Earth. It has been growing, growing, growing at a perfectly straight line, which means the same number of people are added every year. It's 1 billion more people every dozen years. And there's no sign of it stopping. This is 1 billion every dozen years. Remember that number. That's one simple number that you can put into your mind here. Yeah, they're going to close this off in about 8 more minutes. So I'm going to. The sad part is that this population explosion is mostly in the poorest parts of the world. Here's the total population of the different continents. These are what are usually considered the developed continents, North America and Europe. We don't count. There's tiny amounts. South America, you throw in Latin and South America. Doesn't count. These are peanuts. All of the population is in Asia and coming up in Africa. This is where the population problem is. This is where the starvation is going to be, because these people don't have the money to buy food from wherever it can be grown, and they have overpopulation that they cannot, there's no possible way they can grow enough food for themselves. So that's what we have to look forward to. That's why I say things are getting worse. Right now, 1 of every 7 humans is already suffering from hunger. They're hungry now. Experts say that by 2050, not so long from now, we need to produce 60% more food as the world increases to 9.3 billion people. Where would that water come from? In the next 12 years, we have to find enough water to grow enough food for an extra billion people. Ain't gonna happen. And the water to grow food for this next generation of people is being used up now. These aquifers are not going to last forever. Starvation is already here, and it will get worse in the future. Okay, I think I've done my sermon. I don't know if there are any questions or anybody on our panel wants to say something. Can I see the questions? A question to Linnea. Can you direct us to the reference of, yes, I was interested in this also. Can you direct us to the reference to mangroves storing 5 to 6 times more carbon than other trees? It sounds impossible. Linnea, do you have any information?
Yes.
Yes, go ahead.
So my reference is the Ocean Conservancy, is where I got that number. I can dig up the exact document for you if you want. I can send it to you after. And then, is the globalization of food important for continued mangrove loss? So is your question based on the globalization of the food industry? Is that connected to the mangrove loss?
Yes, I was more thinking in terms of mangrove loss for the growing of, say, fish farms and shrimp and things, whether that was an element you'd been looking at.
Yes. It was, absolutely. So I didn't have time to get to it, but a couple of the biggest I guess effects on mangroves is coastal development and agriculture, which in agriculture essentially so I was referring mainly to my research in Senegal, but in a lot of other regions, like Tampa Bay, Florida, for example, there's been a 40% loss in mangroves in that area for these last 100 years. And that's been because of extensive fishing of shrimp. So that's also one of the reasons why these areas have now, the Senegalese government has stepped in to protect these areas even more now, because there's so much clashing and it's hard to regulate as well. When, in theory, when we were talking to fishermen, they were saying, we give these regions breathing periods, 5 months, we do no fishing because that's breeding periods, so that all the populations can rise up again when we fish. But that's in this village. That doesn't necessarily happen all the time in terms of regulations, and that works very differently in areas where people are trying to mass produce shrimp or other fish, and that's when there can be more harm done to the mangroves. I hope that answers your question. Yes. And I can forward you the information on the source itself. Was the Ocean Conservancy that posted this information, but I can delve into it and send it to you.
Please, I have a question for women.
Yes, Francis wants to ask me a question. Let's see, can I share this? Yes. With
the crisis of population in Africa, what do you think we can do to mitigate the impending water problems that are coming upon Africa, particularly Nigeria? What do you think that can be done?
Yeah, Africa is the center of the problem. Technology will help you some, but technology does only some, and it's very slow to be introduced. So we can consider the supply of water basically fixed, and somehow we must reduce demand. Okay. Wait, click this. And it's of course agriculture, as I've been stressing, agriculture that we need, and this is not a rich versus poor problem. Are people still there? Yeah.
Yes.
It is not a rich versus poor problem. It turns out, and there's very good data on this, the sources are mentioned down here, rich people do not actually eat a lot more than poor people. Maybe fancier food, but not more, and don't require a lot more water. The answer, I think, is to empower families to have the numbers of children that they want. And people are not really aware of this, how few children people actually want. This is the Philippines, just as an example of a place that's enormously crowded. There's good data taken by each of these countries' statistical service, and each of these demographic and health surveys asks, do you want more children? And almost everybody in the Philippines wants a few. Some want to stop at one. Most of them want to stop at two, and there's some that want more. In all, 63%, 2/3 of the people in the Philippines want to stop childbearing.
Yeah, that's not the argument.
Can I come in here, please?
We can't hear that. Can you still hear me?
I can hear you. Yes.
Yes. So the question is, they want to stop having children. Contraception is often available. Why don't they use it? And it's interesting. Some of them, of course, want children. So these people are asked, what do you want more children? And are you using contraception? So this is women who are not using contraception, but don't want, not using contraception. A small percent, 15%, 1 out of 6, wants more children. That's a human thing. But the big reasons they don't use contraception is it has health effects. They fear side effects. It interferes with the body's normal functions. They don't understand the medical model. They don't understand the physiology of this. And they hear all these kinds of rumors from their friends, from missionaries, from religious folks, from the government people, that, family planning is going to make you sterile. Family planning is a Western plot to get rid of you. All kinds of stuff. And so more than twice as many people are not using contraception because of misinformation than those that are not using contraception because they want more children.
Can I come in here?
What?
May I come in?
Yeah, go ahead.
Thank you. Are you suggesting that a population that eats 10% of the food of the West is really responsible for all this, when the rural areas of Africa and other nations are used to feed meat production for consumption in the West, which is vastly greater in terms of resource needs and implications for water use? I think you're blaming the victim there, basically. You're blaming the victim.
So with respect to water, that is not really the case. In respect to food, that's not the case. So yes, in the West, we eat meat, and that's been emphasized in rich countries. They eat meat, and more meat than poor countries. My wife knows this very well. But the World Health Organization says this is not, Food and Agriculture Organization says this is not a major problem. Most of the meat in the rich countries that's used is chicken, very heavily of chicken. And chicken actually in modern farming is very, very efficient in the use of resources. So the Food and Agriculture, and so this idea that meat is the problem is overblown. But meat is also grown in scrubland where you can't do agriculture, right? It's too dry for agriculture, so they put the animals out there to graze. So yeah, we have to close soon. But I'm just going to continue with these questions until I think they're going to close us off, the seaweed. So I think those are real issues, but the magnitude of them is not critical. What's interesting is how other people say that you can't deal with population because it works too slowly. You can't change it fast enough. That's also not true. Here, using the China example, The change from bearing a huge drop in many country after country has happened in either a single decade or 2 decades. That as soon as people get the catch, because I showed you they don't want the children that they're having, many places, but they're afraid, or they don't have contraception, or the government opposes it, or their religion opposes it. But it's mostly fear of side effects. But if that changes within a single decade, things change. Here's the China example. The time when their fertility, this is the number of children that average women bear. It's six children. The huge drop was in the 70s when the government made contraception available. The government raised the age of marriage. The one-child policy, which everyone blames for this, was not the cause because it was not introduced till 1980. This is the self-stimulated change. This is before the one-child policy. And then they introduced the one-child policy and not much happens further. So this is a possible solution. And it has great advantage that we have everything there. People everywhere want to control their fertility. They're just like us here. More than half the world's people already use contraception. So it's not like you have to bang people's over the head to use it. We don't have to develop new technology. It's not some futuristic stuff. The contraceptives that we have are very safe and effective now. And they're dirt cheap. We don't need to spend zillions of dollars. The cost for a couple year of protection, that means a man and a woman protected for the whole year. If they put in an IUD, it's 25 cents a year. For a 5-year implant, that's the modern injectables, which are very good, is $2.24 per couple of years. Yeah. Hang on. And this is the last slide. The average cost of all methods is just $270. So people want to control their fertility. We have the technology. It's dirt cheap. So I think that's the low-hanging fruit. That's the possible answer to Francis's question. Okay, now for Adrian, what are the predators of Simulium in West African rivers? Go ahead.
Yeah, thanks. I was just about to type a reply. Just saw that question. I think I don't actually know. I'll be very honest. I don't really know. The flies have a relatively short lifespan, and I think any of the normal predators that go for insects and flying insects would eat them. But I don't think that's very significant. Within the rivers where the larvae are, there are other predators, particularly local fish would eat some of those larvae. But as you saw from the picture I showed, the larvae are in really large numbers. And so this sort of attempt has not really, no one's really tried to look at what predators could be used. In the early program of the West Africa program for onchocerciasis control, they were actually using insecticides and dumping the insecticides on really just very close to the breeding sites. The breeding sites are very specific. They're where the water is well oxygenated. So white water is very, very specific. And the larvae feed by actually, their mouth parts bring in well, microbes and other things that are in the water. That's, yeah. But one of the things they do, exactly, one of the other things they do is that they bring in the insecticide, so that the insecticide has a more specific action on the larvae than it would have on the other fauna in the river. So when they were doing this in West Africa, they were controlling the fauna and also the flora very, very carefully to make sure there was not too much of an upset in the balance. And the problem now is basically, you know, that the flies have come back because those efforts in West African rivers have stopped. The flies are no longer infected, so you don't get the disease, but the flies are now becoming a biting nuisance. And that's, like I tried showing in my last slide, we have to look now how to make people more comfortable because that biting nuisance is really a major problem. So yeah, it's a question of how we can control. We don't know any natural predators, and certainly there's a lot of research going on, you know, in various ways, but we don't have natural predators.
What other questions have we got?
Bob, I
Someone
think
raise a hand, have a question?
Tom Barker's been raising his hand.
Oh, go ahead. No. Says no. And from Francis.
No, go down.
Go down. Okay, I think we're done. I think the whole world is gone. Thank you all for. Oh, Janine, you have a closing statement, which I have somewhere here.
Oh, that's all right. Thank you ever so much, everyone.
Yeah. Okay. So yes, I thank you also. Sorry for that mess up in the beginning. I really don't have any idea. It was working fine. Then I think someone from the Water Week started having control over this, and I couldn't do anything. And then all of a sudden, as quickly as that appeared, it disappeared, and I could have control again. So who knows? But I'm sorry that it happened, and there was no way we could practice beforehand because, see, we didn't let us into anything to do that. All right, everybody. We thank you from all different parts of the world. At least we had fun, I think. Yes.
Okay, thanks very much.
Jane and Tom, I hope you're enjoying vacation.
Bye, everyone.
Bye.
Bye-bye.
Bye-bye, Francis.
Greetings from Nigeria. Yeah,
Bye.
thank you.
Bye.
Let's do it again.